Imagine a world beyond our own, a second home for humanity. Today we delve into the minute-by-minute process of building a base on Mars to colonize it. Mars, the red planet, has captured our collective curiosity since time immemorial. Its crimson hue, observable even with the naked eye, has led to countless stories, theories, and now, the potential for colonization. The idea of setting foot on Mars, let alone establishing a base there, is a testament to our species' unyielding pursuit of knowledge and exploration. But the road to colonizing Mars is laden with challenges that make it an endeavor unlike any other in human history. First, there's the sheer distance. Mars is, on average, a staggering 225 million kilometers away from Earth. That's roughly 600 times the distance from the Earth to the Moon. It's a journey that takes us far beyond the comfort of our Moon's orbit, into the depths of interplanetary space. Then there's the Martian weather to contend with. Mars is, to put it mildly, inhospitable. The temperatures can plummet to a chilling negative 140 degrees Celsius at night, and rise to a barely tolerable 20 degrees Celsius during the day. And let's not forget the thin atmosphere, composed mostly of carbon dioxide with traces of nitrogen and argon, but virtually no oxygen. And yet, despite these seemingly insurmountable challenges, we stand on the precipice of one of the greatest adventures in human history. The dream of colonizing Mars, once confined to the realm of science fiction, is now within our grasp. With these challenges in mind, let's explore how science plans to overcome these obstacles and make Mars our second home. The journey ahead is fraught with difficulties, but as we've demonstrated time and time again, we are a species driven by curiosity and perseverance. So let's embark on this journey together as we strive to make the impossible possible. The journey to Mars is no small feat. It requires meticulous planning and precise calculations. Now, let's delve into the numbers that shape this extraordinary mission. Imagine a journey spanning approximately 225 million kilometers. That's the average distance from Earth to Mars. At a speed of roughly 100,000 kilometers per hour, it would take about 7 months to get there. That's right, 7 months of travel through the vast, empty void of space. Quite the road trip, isn't it? But the journey is just the first step. Living on Mars requires a lot of preparation and supplies. Each astronaut will need about 300 kilograms of provisions per year. That includes water, food, clothing, medical supplies, and other necessities, and that's just for one person. Multiply that by the size of the crew, and the numbers start to become astronomical. And then there's the fuel. The spacecraft needs fuel to get to Mars, and then it needs even more to get back to Earth. We're talking about hundreds of thousands of kilograms of fuel. The exact amount depends on the size of the spacecraft and the specifics of the mission. But no matter how you slice it, that's a lot of fuel. And let's not forget about the spacecraft itself. It's not just a vehicle, it's also a home for the astronauts during their journey. It needs to have enough space for the crew and all their supplies. It needs to be sturdy enough to withstand the rigors of space travel. And it needs to be equipped with the latest technology to ensure the safety and success of the mission. These numbers may seem staggering, but they're what makes a mission to Mars possible. Every kilometer, every kilogram, every minute counts. It's a testament to human ingenuity and determination that we're even contemplating such a journey. These numbers are just the tip of the iceberg. Let's dive deeper into the process of building a base on Mars. Creating a livable space on Mars is a complex process. It begins with a blueprint. Now, what does this blueprint look like? Well, it's a meticulous plan, a precise vision of how to transform a distant, desolate world into something habitable. Let's delve into the specifics. The first thing to consider is the living quarters for our astronauts. We're talking about a habitat with a minimum area of 93 square meters for each individual. Why 93 square meters? It's based on NASA's guidelines for ensuring the physical and psychological well-being of astronauts during long-duration space missions. It's not just about survival. It's about providing a quality of life that can sustain human spirit millions of miles away from home. Next, we have to consider the harsh Martian environment. The radiation on Mars is a major concern. To shield our astronauts, we need to cover the habitat with at least 5 centimeters of Martian soil. This might seem thin, but it's enough to provide a significant reduction in radiation levels. A 5-centimeter layer of Martian soil, or regolith, can cut down the radiation exposure by half. The blueprint also includes a power system. To run a base on Mars, we are going to need approximately 250 kilowatts of power. This is roughly equivalent to the power used by 25 average homes on Earth. The power will be used for life support systems, communication, and of course research. We'll likely have a combination of nuclear and solar power, aiming to create a robust and reliable power grid that can withstand Martian dust storms. All these elements together form a blueprint, a roadmap, a guide to creating a livable space on a planet that has never known life as we understand it. Each detail is crucial, each specification a lifeline. With the blueprint ready, it's time to start building. Building a base on Mars isn't as simple as stacking bricks. It's a process that involves advanced technology and innovative methods. In fact, it's a symphony of science, engineering, and sheer human ingenuity. Imagine this. We're using Martian soil, or regolith as it's scientifically known, not just as the foundation of our structures, but as the very material we're building with. That's right, we're turning the red planet's dust into our Martian bricks. And how are we doing this? Through the marvel of three-dimensional printing, of course. Let's dive a bit deeper into this. The process involves a 3D printer, which combines heat and pressure to transform the Martian soil into a solid, durable material. It's a little like making a sandcastle, but on a much grander and more sophisticated scale. Now, constructing a base on an alien planet is no afternoon task. It's estimated to take roughly 500 days to complete. That's over a year of non-stop construction in an environment that's anything but hospitable. And who's going to do all this work? Well, not humans. At least not directly. The construction will be carried out by autonomous robots, specially designed for this very purpose. These robotic architects will tirelessly work round the clock, under the harsh Martian conditions, to turn our blueprints into reality. This isn't just a matter of convenience or efficiency, it's a matter of safety too. The less time humans have to spend on the Martian surface exposed to the elements and the thin, unbreathable atmosphere, the better. So, we have our Martian soil, our 3D printers, our autonomous robots, and 500 days of construction. It's a monumental task, but one that brings us one step closer to making a home away from home. Remember, this isn't just about building a base. It's about building a future, a new frontier for human exploration and discovery. Once the construction is complete, it's time to make Mars livable. Transforming Mars into a livable space is perhaps the most challenging part of the process. To make Mars habitable, we first need to generate breathable air. This is where our old friend photosynthesis comes in. By introducing oxygen-producing plants and algae, we can start to convert the carbon dioxide-rich Martian atmosphere into one with more oxygen. Next, we have the daunting task of extracting water from the Martian soil, a process known as in situ resource utilization. Scientists believe that Mars holds vast reserves of water in the form of ice, which can be heated and purified for consumption in agriculture. Speaking of agriculture, food production on Mars presents its own set of challenges. The Martian soil, or regolith, lacks the nutrients found in Earth soil. However, with the help of hydroponics and specially engineered compost, we could potentially grow food on Mars. With these steps, we are inching closer to turning the dream of Mars colonization into a reality.